We're going to find the inverse of a 2 by 2 matrix, and I have a theorem for you. And we're in 13.5b. We are up to 13 previous videos for chapter 13 that is all about matrices and determinants. If you've missed them and you become lost or confused, just click in the description, all right? So we can find the inverse of any 2 by 2 matrix if it exists, because it may not, by using this theorem. If matrix A equals these values, A, B, C, D, and this means the determinant. I know this is confusing. If the determinant is not a 0, then the inverse of A, the inverse of the matrix A, is going to be 1 over the determinant. So, see how the D and the A switched places? I'll show you what I'm talking about. Now, if the determinant of A is a non-zero, so it's anything but 0, then that inverse of A exists, okay? So, let's clear up some confusion here. I know you saw these bars on each side of that A, that capital letter A label for the matrix. Well, it's not absolute value. This actually means the determinant of A. That means determinant, okay, with the capital letter A inside. So, when you see this A with this little -1 exponent, that's the inverse of matrix A, all right? We can find the inverse of A if it exists. So here's A. We've got a 2, a 1, a 4, and a 0. If you remember from the theorem, it said it was A, B, C, D. So that's the A, that's the B, that's the C, and that's the D. Now, the first thing we do is find the determinant. We did that in video 13.3a. So you should remember how to do this. We multiply the 2 times 0, we multiply the 4 times 1, and we subtract them. 2 times 0 is 0, minus a 4 times 1 equals 0 minus 4. Well, that's a -4. Now, that means the determinant is not a 0. It's a -4. So we know that the inverse of matrix A exists. Now we swap the A and the D values, the 2 and the 0. We find the additive inverses of the B and the C. So if you see, B is a 1 and C is a 4. So we're going to swap the 0 and the 2, and then that's going to become a -1, and that's going to become a -4, according to the theorem. And then we multiply by this 1 over the determinant, which is a 1 over that -4 that we found, right, when we did the determinant. So we've got a -1/4. Now, this -1/4, if you remember from 13.4a, that's the k value, that's the scalar. We're going to find a scalar product by multiplying this -1/4 to every single element inside the matrix, all right? And that's going to be what the inverse of A equals. So we do -1/4 times 0, and we get a 0. We do -1/4 times -1. Well, that gives us a +1/4 because of the two negatives. We do -1/4 times a -4. Well, that's going to give us a +4 over a 4. Well, that's going to give us a +1. We do a -1/4 times a 2. That's going to give us a -2/4, which simplified to a -1/2. Now we can check this. We can test it by finding matrix A times the inverse of matrix A. So what we do is, here was matrix A with the 2 and the 0 up here, and then here was the inverse one that we just found, okay? And we multiply this one to this one, then we multiply this value to this one. So we're multiplying this column and then to this column, see? So it's like it's going across and then it's going down, all right? Then what we do is we multiply this one to the 1/4 and the 1 to the -1/2, see? And we get our first line. So this is that A value, this is the B value, this is the C value, and this is the D value. See how you have a gap in between here? Because they have a gap in between here. Then we do the 4 to this column, to the 0, and the 0 to the 1. Then we do the 4 to 1/4 and the 0 to the -1/2. All right? When we multiply these and then add their products, we're going to get a 0 plus a 1, which is a 1. We're going to get a 1/2 plus a -1/2. Well, that's a 0 pair. That's additive inverse, isn't it? That's a 0. We're going to get a 0 plus a 0. That's a 0. And we're going to get a 4 over 4 plus a 0. Well, that's just a 1. So, if you remember from the previous video, we got a 1, 0, 0, 1. That's the identity matrix. And it proves that A and the inverse of A are multiplicative inverses. If If you're really confused about this, you got ahead of yourself, all right? We did that in 13.5a, all right? The one right before this one. Now check out this one. It says a equals 3, 6, -1, -2. When we go to find the determinant and we multiply down this main diagonal here, this is the main diagonal. The 3 and the -2 gives us a -6. And then we do the -1 times 6, well, that gives us a -6. And when we have a 3 times a -2, that gives us a -6, and we're subtracting a -6, well, then we have to add the opposite, don't we? These two negatives make us add, so we have a -6 plus a 6. Well, that gives us a 0 for the determinant. And that means that the inverse of a doesn't exist, because remember, it can't be a 0. The determinant can't be a 0, otherwise it doesn't exist, okay? So in this case, the inverse of a doesn't exist, all right? And in this one it does, because the determinant equaled a -4, see? All right, our next video is 13.6a. We're going to calculate the inverse of a square matrix. I'm going to have the link to those 13 previous videos for this chapter, and I'm going to add this one to the Algebra II playlist, so you can just click on the links to help yourself, all right? Try not to skip any steps. You can still go forward if you do, but boy, it's going to be really hard, all right? Can you imagine trying to do long division if you never knew how to add or subtract? You'd be stuck. It would be very difficult, right? So you got to take the baby steps and slowly work your way up, all right? I'm really proud of you, and I'll see you next video. Bye.